You can do PCR in reaction volumes of 10 to 200 microliters in small reaction tubes or microplates. We recommend using thin-walled reaction tubes or plates designed for PCR. There are 7 components in a typical PCR reaction. If you are doing multiple PCR reactions to minimize repetitive pipetting errors and cross-contamination, we recommend making a master mix that includes all of these components except the template DNA. For a single 50 microliter PCR reaction, you will need to add the following volumes of each component to a sterile 0.5 ml PCR tube on ice. Place the primers, dNTPs, template DNA, and polymerase on ice to prevent degradation. To assemble the PCR reaction, it is best to start with the component that is highest in volume, such as water, and then with the one lowest in volume, like the enzyme, as it is easier and more accurate to add very small volumes to liquid in a tube than to an empty tube. Keep track of what reagents have been added to the PCR reaction. Reduce contamination by changing tips at each step, and make sure all the fluid has been pipetted out of the tip. We recommend using tips with the cotton plug that are aerosol resistant. PCR buffer is often supplied with the PCR enzyme and comes as a 10x stock solution containing 100 millimolar tris HCl and 500 millimolar KCl. The pH is between 8.3 and 9.0. Magnesium forms soluble complexes with dNTPs to produce the substrate for DNA polymerase. The most commonly used concentration of magnesium is 1.5 millimolar with 200 micromolar dNTPs. The usual concentration of dNTPs is 200 micromolar of each nucleotide. Always use a balanced solution of all 4 dNTPs to minimize the polymerase error rate. Use high-quality dNTPs since a trace amount of contaminants can inhibit amplification. A good starting place for primer concentration is 100 to 200 picomolar. For details on primer selection, check out the separate video on primer design. Usually, 1 to 1.5 units of Taq DNA polymerase are used in a 50 microliter reaction. Higher concentrations may result in synthesis of nonspecific products. Tap or gently vortex and then briefly centrifuge the tube to bring the contents to the bottom. For multiple samples, you can make a large master mix that includes all of these components, scaled up for the number of reactions you are making, and then dispense 49 microliters of the master mix into each tube. Now you are ready to add the template DNA. The range is 0.01 to 1 nanogram for plasmid or phage DNA and 0.1 to 1 microgram for genomic DNA for a 50 microliter reaction. A higher amount of template DNA than this usually results in an increase in nonspecific products. Cap the tubes and centrifuge them briefly to bring the contents to the bottom. Your reactions are now ready for thermal cycling.